Hi, welcome back to with C++ session 34. In previous session, we have seen the need of destructor, why destructor is needed. So in today's session also, we will see the introduction to destructor, how to write the destructor, how it will avoid the memory leakages, and how we can free the resources. Okay, then just start the destructor concept today. So then what is a destructor? Destructor is a special member function of a class which will be automatically invoked when the object is going out of scope or it is destroyed or disposed. Okay. So destructor, so special member function means it is also like a constructor and it will be destroyed, it will be invoked whenever the object is going out of scope. Maybe like the function is going the controller is CPU controller is going to hit the closing braces of the function, or you are going to destroy the object. So in many ways, either you can say object is going out of scope, or it is going to destroy, or it is going to dispose. During the time, this destructor will be called automatically, so you need not to explicitly call it. Okay, so destructor name should be same as class name with tilt operator prefix. So as and when I say it is a special member function, one thing we have to remember is it should be its name should be same as class name. So for destructor will also shares the same name as that of the class name, but only thing is you have to prefix with tilt operator. Okay, so destructor won't take any arguments, so zero arguments it will take, and we cannot have more than one destructor in a class. Okay, so we can have only one destructor. So because if you want to write any other destructor, so means if you want to follow some function overloading concept to destructors, then it should take the arguments. So since the destructor is not taking any arguments, we cannot overload the destructor. So function overloading concept won't applicable for the destructor, so we can have only one destructor in a class. So what is the job of this destructor? So job of destructor is to free the resources taken by the object before it is getting destroyed. Maybe say you have created an object and that object is trying to reading a file or writing a file, and it is open during its lifetime. Before it is going to destroy, what you have to do is you have to close that file, or maybe your object has taken some heap memory location, a dynamic memory it has taken. You have to free that memory, or your object has taken some semaphores, then before it is getting destroyed, you have to release that semaphore. So these are the examples of the resources you have to release before the object is going to destroy. Okay, so now where exactly I have to write the destructor? So under what access specifier I have to write? So destructors must be present under public access specifier. So if the destructor is not present under public access specifier, your object cannot be destroyed. Okay, so straight away you will get the compilation error. So because objects are getting created somewhere else, not inside your class, it will be created outside the class. So whenever you want to access anything, any member of the class outside the class, then that member has to be present under public access specifier. So destructors must be present under public access specifier. Okay, so now what is the syntax of this destructor? So destructor just like class name, public class name arguments, class name, you can see here. So the first one is zero argument constructor or default argument constructor, default constructor. So second one is parameterized constructor. Parameterized constructor means we can have arguments in the constructor. So now this is destructor. So if you observe here for constructor, zero argument constructor and parameterized zero argument constructor and destructor are having same function signature, but only thing is this tilt operator. If you have removed this tilt operator, then it will be zero argument constructor. Okay, so don't forget to put tilt operator when you're writing the destructor. Okay, for zero argument constructor there won't be any destructor, there won't be any tilt operator. For destructor there will be a tilt operator. Okay, and it should be same as the class name. Okay, and generally all these constructors and destructors has to be present under public access specifier. Okay, so now So here I have some program. I have discussed the same program in the last session. So now just see how it will work. Okay. Second. Let me open the code. Yeah, sorry. Okay, so this is our code. So here I have taken only one pointer attribute int star empid. Okay, one pointer attribute, and here it is a default argument constructor. So means this constructor will work like a zero argument constructor as well as parameterized constructor. I have just kept one cout statement inside constructor, and here I am allocating memory for this and assigning the value here. So since empid is a pointer, right? So it will allocate memory. So now display function, I have one display function. So I am writing display function here. So cout empid equals to star empid. Since it is a pointer, we have to use star, and there is a destructor inside destructor. So what we have to do is here inside the destructor you have to write um, releasing the resource tasks related to releasing the resources. So this class, the C employee, when you create any C employee object, what are the resources it is taking? So it is taking a dynamic memory allocation, dynamic heap memory resources it is taking. So before it is getting destroyed, we have to release this memory. So for that releasing task I am writing here. So I'm checking whether empid is already null or whether it is holding some memory address. So always try to do this before using delete operation. Just check whether the pointer is pointing to valid memory location, or it is whether it is null or it is holding some memory location. So if it is not null, then delete that pointer, and after deleting assign the empid to null. So this is the operations I am doing. Okay, so now in main what I'm doing, I have created one object with 101 as the empid, and second line I have created one pointer, and for this pointer I am creating object inside the heap. Okay, so one object, so totally I have created two objects here. One object is inside the stack frame and another object is in heap segment. Okay, by using stack segment object I am displaying the function like this, event dot display, and by using heap segment, so heap segment object I cannot directly access. So what I have to do is I have to use the pointer. So eptr arrow display. So now once it is done, once all operations done, then what I'm doing is I'm doing delete eptr. So when I'm doing delete eptr, then what will happen is, so it will first it will check, the compiler will check what is the type of this pointer. So eptr is of type C employee. So then it will check have you provided any destructor for this class. So yes, we have provided. Now it will trigger the destructor of this class. So this destructor, what it will do, it will delete the employee ID, free the memory location, heap memory location, and it will print the it will remove the pointer also. Now when once you do a return 0, now this even object will also is going to destroy. Now for even object also, since this object is also going to destroy, so it will call destructor for this even object also. So totally we are creating two objects, right? So one is stack segment object and another one is heap segment object. So what we are expecting from this output for this program is constructor has to be called two times, that is inside constructor has to be printed two times, and destructor has to be called two times. Inside destructor has to be two times, because two objects we have created, two times constructor should call and two times destructor has to be called. Okay, and as usual whenever I have used a display function, this display it will display this. Okay, so now just check. Let me compile this. Okay, I'm generating debugging symbols also. So okay, before that, let's see inside constructor, the output is inside constructor, two times constructor is called. So after that, for the first object, emp id is 101, and second object emp id equals to 120. Okay, so objects before now after this, after the display function, we have, if you see the code, so after EPTR arrow display, we are doing delete EPTR. So that is the reason what it is happening, what it is doing, it is calling the destructor. Okay, so now let's observe this, sorry. Okay, now let's do the debugging. tdb a dot out. Okay, I'm putting the breakpoint at main. Okay, now run it, do single step. Okay, so the first thing is employee e1. Now the constructor for e1 will be called. Okay, see, now constructor is called with id equals to 101. Okay, so now inside constructor, so it is printing inside constructor. Okay, correct. Now emp id equals to new int id. Now the object, e1 objects employee id, memory is allocated in heap segment, and the value is 101. Okay, so now constructor is coming out of this, constructor is closed. Okay, now again we are coming back to main function. Okay, now let's see what is the address of this pointer is holding this value, right? Now just print the address of e1 object. Okay, what is that? See, you can both are same, right? Now what is the next line I'm going to execute? That is this one, c employee equals to star eptr equals to new c employee. So we have while discussing this new and delete operator, we have seen that new always will call the constructor. Okay, so now let's see whether it is calling the constructor or not. See, now it is called the constructor. Okay, so inside, what is the value I'm passing? 120. Now this dynamic object is getting created. Okay, inside constructor, for dynamic object, that is this object is getting created in heap segment, and in that heap segment also we have emp id. For this also memory is allocated in heap segment. Okay, so now once the construction is done, so then we are coming back to again to main function. Now let's print what is the value present in eptr. Okay, can you see here, this is 0x 555 at b2ea0. So means this pointer is holding this object. Okay, right. So this is not this is a pointer, but we won't get the object of this. If you want to get the object of that, what you have to do? Print dynamic objects information. If you want to get, then you can say print star eptr. Sorry. Yeah, so you will get this memory location only. Employee id, again see, for employee id again memory location is allocated in heap segment. Okay, so now let's continue this, continue the next line. So what I'm doing, e1 dot display, sorry, the next step is we are doing delete, right? Delete operation we are doing. So when you say delete destructor, it's called, oh, I'm sorry. So we are calling e1 dot display. So display function is triggered. Okay. Next EPTR arrow display. So display function is triggered now. So the next line is delete EPTR. So however the new will calls the constructor in the same way, whenever you are using delete will calls the destructor. So here destructor, whose destructor it will call. Now whenever the compiler, what it will do is it will check what is the type of this eptr is of type class c employee, right? Now it will call the destructor of C employee. Now see here, so destructor is called for this EPTR. Now see destructor, inside destructor, okay, if empid delete empid, okay. Now I'm just going to hit the closing curly brace, return 0. When I say return 0, still we have one more object. What is that object? Even. Even I'm not calling this destructor explicitly. Okay, since we are coming out of the stack memory or that main function, even object is also going to destroy. It will go out of the scope. Now destructor will be called for even object also. Let's see. So it is called even, for even object also destructor called. Inside destructor, delete tmpid. Now it's done. So we are coming out of the, so that's about our program. Okay, that's completion of debugging. So totally how many objects we have created here? So we have created totally two objects. Okay, one is a stack object and another one is heap segment object. For stack segment object also constructor is called, for heap segment object also constructor is called. When you are doing delete, that time for the heap segment object also destructor called, and when we are coming out of the scope of the main function, that time for stack segment object also destructor will be called. Okay, right. Now just analyze, just say pictorial representation of this, how it is getting memory allocation and deallocation. Okay, so now, so when I say C employee obj1 here, so what will happen is, first let's take stack and heap segment. So first obj1 memory is allocated in stack segment, and the so as soon as memory is allocated, there you can see one empid pointer will be there. Okay, so now the constructor will be called. So what is there in the constructor? So here we are saying int id equals to 100. Okay, so now constructor, inside the constructor empid equals to new int id. So for this pointer we are allocating memory in the heap segment. So in the memory heap segment memory, some 4 bytes of memory will be allocated and the value is initialized with 100. Now this address 0x2000 will be given to this empid. Okay, so now this empid is pointing to this memory location. Now obj1 is a stack object which is having a pointer attribute called empid, and this pointer attribute is holding address of an heap segment memory where an integer variable is created which is having the value 100. Okay, so this is obj1. Now in the same way, now I am creating, so once we do obj1 dot display, it will print this value. Next what I am doing C employee star ptr. So in this case one pointer variable will be created in the stack segment ptr. Now for this pointer what we are doing is ptr equals to new C employee 102. So now for this ptr memory will be allocated in the heap segment. When you do new, it will allocate memory in the heap segment. So in the heap segment first one object will be created. So here however the stack segment object is getting created first, here also one heap segment object is getting created. Once this heap segment object is getting created, so then constructor will be called for this with the value 102. Now what constructor is doing? empid equals to new int of id. So for this empid again it will allocate one heap segment memory. Okay, and it will initialize the value 102. So once the value is initialized, this address 0x2202200 will be given to this empid. Okay, now it is pointing to this. See, here obj1 is a stack object and whose empid pointer attribute is pointing to heap segment memory. Here 0x2100 is a heap segment object and whose pointer attribute, that is empid, is also pointing to an heap segment memory where an integer variable is created with the value 102. And once the initialization is done, this value, the heap segment object's address, that is 0x200 2100 will be given to this pointer. Okay, now this pointer is pointing to this. Now when you say ptr arrow display, then it will call the display for this, where we are displaying the this employee IDs value, that is 1 or 2. Okay, so till here no problem. Now I am doing delete ptr. So when I do delete ptr, what is happening is, first it is going to the destructor. So ptr is of type c employee. In c employee there is a destructor. So here we are checking whether emp id is null or not. So this emp id is not null. So then what it will do is, it will delete the employee id. So this memory will be deallocated. So that memory, that heap segment memory will be delocated wherever this EMP ID is pointing. So after that, what will happen, for this EMP ID, null will be assigned. So then after that, this particular memory will be freed from the heap segment. Okay, right? So then this particular PTR will be removed from the stack segment. So now still after delete PTR, we are doing return 0. So before going to return 0, then still we have one more object. Whenever this object is going to destroy, again destructor will be called for this object also. So you need not, we are not triggering it manually. It will be triggered automatically. So destructors will be automatically triggered whenever the object is going to destroy. Now this, for this obj1 also, destructor will be called. So here again we are checking employee id. Employee id is not null or not. Yes, not null. So then delete this emp id. So this memory location will be removed from the heap segment. Once it is removed, then it will remove the stack segment memory. So now is there any other objects present in the stack segment? No. So stack segment memory, heap segment memory is freed. Now there is no memory leakage. So this is how we can make use of destructor. So by using destructor, we can release the resources taken by the object during its lifetime. Okay, so few of the points we have to remember. Destructors and zero argument constructor function signature is same, but destructor name is prefixed with tilde operator. So if you see a zero argument constructor and destructor, both looks like same, but only thing is for destructor tilde operator will be there. Okay, so don't get confused with zero argument constructor and destructor. So if we have a tilde operator, then it is a destructor. Destructor will be called automatically only once when the object is going to destroy. Okay, for the same object two times it won't call destructor. So only one time it will call the destructor. So destructor has to be public member functions, because always the destructors will be triggered from outside the class. So if you want to access anything outside the class, then those class members has to be present under public access specifier only. So unlike constructor, destructors overloading is not possible. So why it is not possible? Because destructor won't take any arguments. If it is taking any arguments, then what we can do is, based on the argument types, or based on the type of arguments, or order of arguments, or number of arguments, what we can do is, we can write the many number of destructors. But destructor overloading is not possible because it is not taking any arguments. So all the resource cleanup task has to be present in destructor. So write the cleanup tasks in destructor only. Okay, so constructor will be called when the object is getting created, and destructor will be called when the object is getting destroyed. Okay, so these points you have to remember. So constructor will be called when the object is getting created, and destructor will be called when the object is getting destroyed. So in the same way, new will call the constructor, and delete will call the destructor when you are dealing with the user defined data types like class. Okay, so that's for today. Hope you have understood. Thank you. Thanks for watching.